What's up guys, it's Simon Fiaz and today's video is on AQA A-Level Chemistry Transition Metals Multiple Choice Questions. Now I have not been posting a lot consistently on this channel, and I did say whole of April extremely consistent as that. So starting from tomorrow, yes, I will definitely be extremely consistent. Every kind of thing I'll be going through. Practicals, mechanism, etc. etc. So don't know what's going on here. Okay. Question 1. Which compound can decolorize acidified potassium manganate solution FeSO4? You do need to know these equations off by heart so you can spot it just like that. Which compound decolorize acidified potassium manganate? Is that the same question? It's not the same question. You can see the different kind of wording. It's literally the same question, but we've just changed the options in the wording. It's FeSO4 again. How well do you know your equation? And that's why they like to include this one in these multiple choice questions, because a lot of students think they can get away with, including myself, not memorizing the equations. No, it'll come back in paper 3 with a multiple choice question, and if you don't know the equation, you're not going to get the mark. Question 3. Which one of the following would not reduce an acidified aqueous solution of potassium dichromate 6? Zinc definitely does. Same with Fe2 plus aqueous. I'm left with this. Now, yeah, it's going to be A, ethanoic acid. In this case, I've got what? Methane, ethane, ethanol, right? I've got ethanol aldehyde. So would reduce acidified aqueous solution potassium dichromate, because an aldehyde. Aldehyde, and remember aldehyde does reduce acidified aqueous solution of potassium dichromate, whereas this ethanoic acid will not. So that's a nice little question. Question 4. Which of the following can act as an oxidizing agent but not as a reducing agent? So it's testing your definitions on both, right? Now, oxidizing agent electron acceptor, reducing agent electron donor. So which one can accept electrons but not donate electrons? Now I know what. Now I'm able to convert these two words to an actual understanding. Electron acceptor, and but it's not an electron donor. So A definitely can accept electrons. And it can act as an electron donor, so not going to be A. B definitely not for both of these conditions. C, I minus. Yep, that can. MnO4 minus. And again, if you knew these equations like really intensively, like you knew the ins and outs of them, you'd be able to spot it in a second. It's MnO4 minus. Question 5. Aqueous C2O42 minus reacts with MnO4 minus acidic solution called equation. Under the same conditions, Fe2 plus ions also react with MnO4 minus. ions. How many moles of MnO4 minus ions are required to react exactly with 1 mole of this? Well, remember, it is a... I'll get the equation up right now. It is a... So, what is it again? Fe2 plus ions also react with MnO4 minus ions. So, Fe2 plus MnO4 minus. How many moles of MnO4 minus are required to react exactly with 1 mole of this? It's going to be 0.6 then. Question 6D. Sorry, question 6. Oxidation of ether dioate oxalate ions by manganate ions can be represented by the half equations. What volume in centimeter cube of 0.02 m of KMnO4 is required to oxidize completely a solution containing this much of ether dioate ions? Well, C242 minus ions, these ions, what volume in centimeters cube of this much of MnO4? Four. It's going to be D then. 400 centimeters. 400 centimeters cubed. Question 7. Percentage of iron in a sample of impure iron 2 sulfate crystals can be determined by titrating solutions made from separate weight samples acidified by dilute sulfuric acid against a standard solution of potassium manganate 7. Which one of the following would lead to the greatest error in the calculation percentage of iron 2 in the sample? Error of this made when weighing out a sample of this. So 0.005 over 0.97. Endpoint error of this 25. An error of this when measuring out 25 centimeters cubed sulfuric acid. Using the average of the tide values 25.4, 25.7, 25.9, and the correct value is 25.5. Well, if I work this out, let me work that out. Actually, let me work all of them out. 0.005 over 0.987. I'm just gonna treat them as percentage errors, even though it says lead to the greatest error, just because these are very small numbers, so I'm gonna make them feasible. 0.5 or 7%. And then times by 100. 0.4%. 20%. And this one, 25.4 plus 25.7 plus 25.9 divided by 3. Well, that will give me 25.6 recurring to power 7. Therefore, to find out the percentage error, going to be that. So it's going to be 25.5 over whatever this is divided by 3, add them all up, divided by 3, times by 100, and you get 99.4%. So definitely D will lead to the greatest error. And now this one is, let me guess, a practical question. Well, let's see. Percentage of iron in a sample of impure iron 2 sulfate crystals can be determined by titrating a solution made from separate weighed samples acidified with dilute sulfuric acid against standard solution of potassium manganate. 7. Which one of the following will lead to an accurate result? Transferring the weighed sample of iron 2 sulfate into a wet conical flask. Failing to measure accurately the volume of water used to dissolve each weighed sample of iron 2 sulfate. Transferring the standard solution of potassium manganate from its original container to using a wet beaker, or failing to measure accurately the volume of dilute sulfuric acid added to the mixture before titration. These practical multiple choice questions are very, very difficult, and yeah, I just want to let you know that they're very, very difficult. So you might have to do hundreds of them just to see what they want to really assess in terms of each practical, etc., etc. The answer, though, well, think about it logically. Transferring the standard solution of potassium manganate from its original container to the beer using a wet beaker, it's going to have water in it, and therefore that is going to lead to an inaccurate result. So C is the correct answer. And that's the end of the multiple choice questions.